Welcome back, ladies and gentlemen. In this video, we are going to discuss the third of our triangle congruence theorems, and that is our hypotenuse leg theorem. So our goal continues for this whole section, to be able to utilize side-side-side and hypotenuse leg theorem to prove that mathematical statements about congruent triangles. Today, in this specific video, I want to talk about defining what the hypotenuse leg theorem is, breaking it down a little bit, of course, and then utilizing it in a proof regarding triangle congruence. So let's first talk about what is the hypotenuse leg theorem. Well, first and foremost, ladies and gentlemen, notice the very first thing that we see here, hypotenuse. The name, hypotenuse. What does that tell you? Right off the bat, hypotenuse only happens in right triangles. There's no hypotenuse of an acute triangle. There's not a hypotenuse of an obtuse triangle. Sure, there's a longer side of an acute triangle. There's a longer side of the obtuse triangle. We don't call it the hypotenuse. We call hypotenuse the longest side of a right triangle. Specifically, remember, it's that side that is across from the right angle. So, given that we have a right triangle, sometimes we may need to physically prove that it is a right triangle. So given that it is a right triangle, if you can prove that the two hypotenuse are congruent and the same corresponding leg are congruent as well too, then that's enough information to prove that the two triangles are in fact congruent to one another. So let me say that one more time. If you can prove that it is first and foremost two right triangles and that the hypotenuse, because of course they're going to correspond to each other, the hypotenuse and the two corresponding legs are congruent, then that's enough information to prove that it is a two congruent triangle pairs. So let's talk about a first proof utilizing it. We are given that WY is congruent to XZ, and as always, if I'm not given markings, the very first thing I'm going to do is I'm going to start marking up the diagram as much as possible. So I'm given that WY, so the whole hypotenuse, WY, so I'm going to try to kind of put it a little bit towards the middle, just so I know it's all of WY. And I know that all of XZ is congruent as well. It says that WZ is perpendicular to ZY, and likewise XY is perpendicular to ZY. So good. I know the hypotenuse are congruent, and I do know that we have two right angles in there, so it's going to be really simple to make sure that we can prove that it's a right triangle. So now the last goal will be to prove that one corresponding leg is congruent. Well, what do you see here? Well, take a look at what's happening. ZY is a shared side. Now, it's not like a lot of the shared sides we've seen where it's kind of been straight up in the middle, but it is still a shared side. ZY overlaps on each other in this case. So I will show that ZY is congruent to itself by the reflexive property in this proof as well. What do we know? WX is congruent to XZ. That's the H. That's our hypotenuse that we're going to be looking for, and we already found that, so it's given to us. Well, then what else are we given? Two different sets of perpendicular lines, okay? And that's given to us, and that's good. Because what does it tell us? Again, you have to ask yourself, what does it physically mean to be perpendicular? Every time we're doing proofs, you've got to make sure that you're wondering, what does it physically mean for the previous step to happen? And so you say, hey, what does it actually mean for WZ to be perpendicular to ZY? It means that this angle right in here, WZY, is right. Right? That's what it tells me. And this angle right in here, in this case XYZ, but really it's just angle Y, right? Angle Y in this triangle is a right angle. That's what it tells us. That's what it tells us. And so that is because we know what the definition of perpendicular lines is. Again, think about what the question I asked you. I said, what does it physically mean? When I say mean, we're talking about definitions that we're going to be utilizing in our proof. Okay. So what does this do for us? Well, remember, let me go back real quick. Remember what the theorem said. In a right triangle, you have to prove the triangle is right if you're going to use hypotenuse leg theorem. Now, I will say that there are a lot of people out there that are doing proofs using hypotenuse leg theorem that kind of skip this step. And in my personal opinion, you can't skip it because you got to prove that you are working with right triangles. And so, again, how did I know that these were going to be right triangles? Because the definition of a right triangle is that it has a right angle. We proved that it had two right, or a right angle in each, I should say. Okay, good. So let's retrack. I have my hypotenuse. I know that my triangles are now right, so I'm allowed to use the hypotenuse leg theorem once I've proven that. And so now we can go ahead and say, well, what's the other thing we said? We wanted to prove that this leg, zy, was congruent to itself by the reflexive property of congruence. Again, I switched the order in this case because z matches with y and y matches with z, respectively, in those two triangles. Okay, so hypotenuse, leg, I've proven it's a right triangle. I'm good to go. The two triangles are congruent by the hypotenuse leg theorem. And that is our first example utilizing HLT.